Welcome to the video lecture on polynomial functions and their graphs. So we have already discussed about quadratic functions and their graphs. So quadratic functions are actually polynomials with highest power 2. So in this section we will be discussing polynomials of powers higher than 2, like cubic polynomials and so on. Okay. So this is the general definition of a polynomial. So polynomial is any function like this with these coefficients being independent of x. Okay, so this can be like any finite power. Okay, so an is called the leading coefficient, and we will go through some examples. So this is a polynomial. This is also a polynomial, even though this coefficient is irrational. So these are all integer powers, positive integer powers. So this is not a polynomial because this is actually the square root is x to the power 1/2. Okay, so this is not a polynomial. This is also not a polynomial because if you have x squared on the bottom, if you take it up, it will be x to the power -2. So negative powers are not allowed in polynomials. Okay. Continuity and smoothness of graphs of polynomials. So polynomial functions have graphs that are continuous and smooth. What we mean by this is that what we mean by continuity is that the graph of a function has no breaks and can be drawn without lifting the pencil. And what we mean by smooth graph is that it does not contain any sharp edges. So this is a continuous smooth graph. So this is actually a graph of a polynomial. This is not a graph of a polynomial because even though this is continuous, it has this edge which is pointed. This edge is not smooth. Okay, so this is not a polynomial. Again, this one also, it's not a graph of a polynomial because this graph is discontinuous. Okay. Okay. In behavior of polynomial functions, the behavior of a graph of a function to the far left or the far right is called the end behavior. This has a much more precise definition which you will learn in more advanced courses. So, in calculus you will learn something called the limit of a function. So here we are only like having a rough idea saying far left and the far right. So given a polynomial function, the end behavior of the function is always dominated by the term with the highest power. Okay, so if n is odd and n is positive, f rises to the far right and falls to the far left. If n is odd and n is negative, f falls to the far right and rises to the far left. Okay, and if n is even and n is positive, then f rises to both the far right and the far left. And if n is even and n is negative, f falls to both the far right and the far left. Okay, this will be more clear when you like look at some graphs of functions instead of like reading this presentation. So consider this function. So this term with the highest power is 2x cubed. So when x goes to the far right, this will be a very big positive number, and when you cube it you get a even bigger positive number, and when you multiply it by a positive number you get another positive number. So when you make this bigger and bigger, it will like go upward. Okay, and when you go to this side, if you plug in something like negative 10,000 or something, the cube of a negative number will always be negative. Okay, so it will like and when you multiply it by a positive number, you again get a negative number. So it will go downward when x goes to the far left. Okay, so that's how it behaves. So now when we have this coefficient, so if the coefficient is negative, then when x goes to the far right, this becomes a very big positive number multiplied by a negative number. It will give you a negative number, so it goes down. And when you go to the far left, this will be a very big negative number multiplied by a negative number. You'll get a very big negative when you multiply a very big negative number by a negative number, you'll get a very big positive number. Okay, so when you go to the far left, this will increase, this will go upward, because x is negative, x cubed would be negative, and multiply it by a negative number, it will become positive. Okay, so what about this function? So here when you so this is even. Okay, so here it was odd, here also it was odd, but here it's even. So when the power is even, so when you so even power of a positive number would be positive, and even power of a negative number would be negative, like x squared. Okay, so this is x to the 4. So even x to the 4, when you have something like negative 2, this will give you a positive number. Okay, so for both ends, if this is positive, if the coefficient is also positive, it will rise. Okay, and if the coefficient is negative, so then this x to the 4 will be positive for both positive and negative numbers, and this negative, by multiplying a positive number by a negative number, you'll get a negative number. So it will fall when you go to the far left and as well as far right, because this will become a really big positive number, and multiplying by negative 3 will make it negative, and it will make it go down. Okay. Okay. Zeros of a polynomial function. Given a polynomial function f, the values of x for which f of x is 0 are called zeros of the function. Okay. So in fact, it's zeros are just solutions, and also called roots of the equation f of x equals 0. So that means for which values of x does the function is 0. So those values of x are called zeros. Okay, each real zero of f constitutes an x-intercept in the graph of f. So this zero being real is very important for the x-intercept. If the zero is complex, then it will not constitute an x-intercept. If a is a zero of f, then x minus a will be a factor of f of x. If x minus a is a factor of f of x, then a is a 0 of f. So you may have experienced this when factoring quadratic functions and solving quadratic equations. Okay, when you are factoring when you use factoring to solve quadratic equations, you may have already come across this. Okay, so this is kind of the same thing that we are like discussing. Okay, same thing, but now extended to higher powers. Okay, so example, finding zeros of a given polynomial. So that means to solve this quadratic equation. Okay, so you factor it, and factors give you zeros or roots or solutions. Okay, so it's the same thing. So now we go to some difficult functions. So in this function, now you have negative x plus 2 and you have x cubed minus 2x squared. So if you take out x squared out of these two terms as a factor, you will have x minus 2. And if you take out negative from negative 1 from these two terms, you will have this will become positive x and this will become negative 2, and you will have x minus 2 here from these two terms and x minus 2 from these two terms, and you can take it out and factor it. So let's see how we are going to do this. So take out x squared from these two terms. You take out x squared, you are left with x. When you take out x squared, you are left with negative 2. When you take out negative 1, you are left with x. So what we do is you divide negative x by negative 1, then you get x. And when you take out negative 1 from positive 2, you get negative 2. So you divide positive 2 by negative 1 and then you get negative 2. Okay, so when you like send it back, when you distribute it, you must get the same thing back. Okay, so now you have two terms, this term and this term. Okay, so you have two terms. Now from these two, is there a common factor among these two? X squared times x minus 2 and negative x minus 2. So x minus 2 is common for both. So you can take out x minus 2 as a common factor. Okay, not only so you can so not only things like x squared and negative 1 or 2 or anything, you can also take these big parentheses also as common factors if they are common. Okay, so even if you had 3 or 4 terms, if it's the same thing, you can take it out as a common factor. So not only things like x squared and negative 1, you can also take these things as common factors as well. So what do you get when you take x minus 2 as a common factor? So here when you take x minus 2, you are left with x squared, and here when you take out x minus 2, you are left with negative 1. So you divide negative x minus 2 by x minus 2, then you are left with negative 1. Okay, okay, now this is the equation. So you can further factor this as a difference of two squares and you will get this. Okay, so you have to remember how to factor difference of two squares. Okay, so you have three real solutions. Okay, x equals 2, 1 and negative 1. Okay, so you have three real solutions for this equation. So this function has three real zeros. So actually three distinct x-intercepts. Okay, so the function intersects the x-axis at three different locations. Okay. Okay. Finding zeros of a given polynomial. find the zeros of g of x equals x cubed negative 4x squared plus 4x. So again, this problem is something like what we did earlier. So you have to factor it and then solve. So g of x is this, and x is common for all three terms, so you take out x, then you are left with this. So this is actually a complete this is a perfect square. So this is actually x minus 1 squared. So if you expand this, you get this. So it is actually x minus 1 times x minus 1, so it's x minus 0. So x is actually x minus 0 and x minus 1, x minus 1. So zeros of g are 0 and 1. So in this polynomial, the factor x minus 0 appear once and the factor x minus 1 appear twice. So we say that 0 is a 0 of multiplicity 1 and 1 is a 0 of multiplicity 2. Okay, so when you look at these factors, you see that you have x minus 1 two times. So in this case, now 1 is a 0 of this function, and we say that 1 is a 0 of multiplicity 2, and here 0 is a 0 of multiplicity 1 because you only have one x minus 0 factor. Okay, so this is the, so if you have like the same factor multiple times, it will just increase the multiplicity of that corresponding 0. Okay, so multiplicity of a 0 of a polynomial. So if a is a 0 of polynomial f and the factor x minus a appears k times in the factorization of f of x, then we say a is a factor, then we say a is a 0 of multiplicity k. Okay, a is a 0 of multiplicity k. Graphs of polynomials intersect the x-axis at real zeros of odd multiplicity, and graphs of polynomials bounce back touching the x-axis at real zeros of even multiplicity. So this is important when you are going to sketch graphs of polynomial functions. Okay, now sketching the graph of a polynomial function. So let's try this example. So before sketching, you have to check the end behavior. So this one will fall to the far left and rise to the far right because it is because this x cubed term, the term that has the highest power, has the power is odd. So when x becomes a very large positive number, this will be a very even larger positive number. And when you go to the far left, the odd power of a negative number will be negative, so it will fall to the far left. Okay, so and the coefficient is positive 1, so it's just this. So that's the end behavior, and you have to factor f of x to identify the zeros. So zeros are the actually zeros are the x-intercepts. So you have to find zeros so as to find the x-intercepts. So for that you have to factor this. So if you like see this, you can see that x minus 1 will be a common factor for these two terms and these two terms. So you take out x squared out of these two terms, then you are left with x minus 1, and you take negative 1 from these two terms and you are left with x minus 1. So you divide this by negative 1, you get positive x. You divide positive 1 by negative 1, you get negative 1. then you take out x minus 1 as a common factor, then you are left with x squared, and when you take out x minus 1 here, you are left with negative 1. But this can be further factorized as x minus 1 times x plus 1. So zeros are 1 and negative 1, and 1 is a 0 of 1 is a 0 of multiplicity 2, and negative 1 is a 0 of multiplicity 1. Okay, so from this you get, so the 0 would be 1, positive 1. Here also it's positive 1. So 1 is a 0 with multiplicity 2, and from here you get negative 1. So negative 1 is a 0 of multiplicity 1, because this factor appear only once. So x minus 1 appear twice. Okay, so the graph will touch the x-axis and bounce back at x equals 1, and will intersect the x-axis and go to the other side at x equals negative 1. Okay, now these are x-intercepts, and we have to find the y-intercept as well. So y-intercept, as in the previous like when we did quadratic functions, is f of 0. So if you plug in 0 for x, you get the y-intercept, which is so this will be 0, it will be just 1. Okay, and then draw. So at this x intercept, it will only touch and go. Okay, and at this x intercept, it will cross the x-axis. Okay, so how we are going to draw this is, now we know the end behavior, so it has to come from this side, from the bottom, because to the far left it falls. Okay, because of the odd power of the leading term, and the coefficient of it is positive. So it goes down, and it comes like this when we increase x. So it has to go through negative 1, because negative 1 is a 0 of multiplicity 1. So that's why it crosses the x-axis, and it goes like that, and then you have the y-intercept, and then 1 is a 0 of multiplicity 2, so it will not cross the x-axis, it will bounce back and go to positive infinity as we go to the when x goes to the far right. Okay, so that's why we need the that's why multiplicity is important, so that from that we can determine whether it crosses the x-axis or it bounces back. Okay, so if it came from this side, it will bounce back like that and come like that. Okay, but there's a limitation in sketching graphs like this. So without the knowledge of calculus, it can be impossible to find the locations of all turning points. Now here this turning point, so it can be like, so the graph can go like, even this is possible. Okay, so we don't know the exact position of this turning point. It can be even at this point, it will at x equals 0, 0, 1. So even here it can be possible. So we cannot find the this local maxima. So the coordinates of this point we are unable to find. Okay, so we are unable to find the coordinates of this point without the knowledge of calculus. So we cannot find the maximum value, and also when it actually occurs. So we cannot find the x coordinate as well as the y coordinate of this maxima. So that's actually a limitation of the things that we study in this course. So if you study calculus later onwards, you will learn how to find the exact location exact coordinates of this point. So without calculus you cannot determine where this will occur. So it can even be like that. It can be so 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 this point can be like anywhere, like if not for a computer we cannot graph it with the knowledge we have in this course. With calculus you can, but now this graph is actually drawn by a computer, so this is correct. But at when you are doing this at exams, um, you will not be able to find where will this maximum value will occur. So so we will give credit even if you draw something like that, but all the other things has to be correct. Okay, so with calculus you can find it. So this graph, the actual, so this is the this is the actual location of this maximum point, this turning point. So because this graph was drawn using a computer, so either you need a computer or you need to know calculus to find this point. Okay, now turning points of graphs of polynomial functions. A polynomial of degree n can have at most n minus 1 turning points. So also that can be proven using calculus, but in this course we are not going to prove that. So without the knowledge of calculus, it may be impossible to find all turning points of many polynomial functions. For example, so like here you have 2 turning points, so this one would be like impossible to think of, like so sometimes it can be like 1 turning point, sometimes there can be like, so this instead of having 2 turning points here, it can be like it so sometimes there won't be any turning point, so it can go like that. Okay, so we cannot find this behavior without calculus or computer. Okay, so it can like go like that without without having any turning point in this part. Okay, so that all depends on the given function and these coefficients and things. Okay, so that's all about polynomials and their functions. Thanks for watching.